Okay, so in the my voice is audible.
Yes, sir.
My voice is audible to all.
Yes, sir.
Yes, sir.
So yesterday, I think in the last lecture, the previous lecture, I have given you one problem to solve. Have you solved that problem?
Yes, sir.
Yes, sir.
You have solved it. What about you, Deepak? Have you solved the numerical? Why? It is for homework, I told that, no? Today solve it. We will take the next numerical. So, who has solved the numerical? Can you tell me the answers? What is the value of y bar?
Y bar is, sir, 17.5. 17.5.
Okay. And what is then Ixx? What is the value?
Ixx is 500, 505 into 10 raised to 3 raised to 4.
Here the answer with me, it is 330.83 into 10 raised to 3. So please once again check the numerical. Okay. Y bar, it is near about value. Here y bar 18.75 is the answer. You have got some 17.7. It's okay. That will be okay. But while calculating Ixx, once again check the values. Okay. I don't know whether it is correct in the or not what is there in the notebook, because I have not solved this problem. But you once again check the numerical, and if you get the same answers, then let me know. I will correct here. Okay. Or otherwise,
दोन ते तीन वेळा सोडवले हेच आले आन्सर आणि माझ्या एका फ्रेंडने पण सोडवले त्याला पण हेच आले आन्सर.
Okay, okay. Okay. Others, those who have not solved the numerical, please solve it, and tomorrow again we will verify the answers. Okay. So now we will take the next numerical. Determine the MI of built up section shown in the figure. About an axis passing through the topmost fiber of the section. We need to calculate the moment of inertia. Now I will draw the diagram. So this is the given diagram. Okay. Now we will write the dimensions and the axis. First of all, we will show the axis. We need to find out the MI of built-up section shown in figure about an axis passing through the topmost fiber of the section. So this is the topmost fiber. This layer is the topmost layer. So our axis is here. This is the axis. Okay. Let us name this axis as axis AB. As it is not the centroidal axis, we can give any name. Okay. So AB is the name of this axis. Now the dimensions are also given. So this total dimension is 400 mm. Then its depth is 20. So this is 20 mm. Then here this is 10 mm. Okay. And here at the bottom, this is 100 mm. This is also 100 mm. And in between it is 150. 100 mm, 150 mm, and 100 mm. And its height, this is 380. Okay, so height from this point, yes, this height, it is 380 mm. Okay, so these are the given dimensions and this is the given diagram. Now we want to calculate Ixx. Okay, they have not asked us the centroids. Problem मध्ये विचारले का तुम्हाला centroid calculate करा म्हणून. Okay, they have not asked us the centroid, and as they have also not asked us the moment of inertia about the centroidal axis. See the difference in the problem. In this numerical, they have not asked you to find out the centroid. This is the first thing. This is not asked. Second, they have not asked to find out the MI of section about centroidal axis. Okay, about centroidal axis means what? Means Ixx is not asked in the problem. Okay, Ixx and Iyy. This is also not asked in this problem. In the previous problems, what they ask us generally, this is the composite figure, then find out what is Ixx, then find out what is Iyy. So these Ixx and Iyy, they have generally asked us about the centroidal axis if you refer the previous problems. So that is why it is necessary for us to calculate the centroid, because when we locate the centroid, then only we get the position of this Ixx and Iyy. Okay, and that the moment of inertia of this we need to find out in the previous numericals. Now, what is the difference in previous numerical and this numerical? Here they told you to calculate the MI about this axis AB, which is not the centroidal axis. First thing. Second thing is that they have not specifically told you to calculate the centroid. Okay, so these are the two things over here. So in this numerical, we won't need the centroid to solve this problem. See how. See, suppose now I have divided this figure into number of known areas. Suppose this is my rectangle 1. Suppose this is the rectangle 1. Okay. Now I know that CG of this rectangle may be situated somewhere here. This is the centroid. Now AB axis. AB axis is the horizontal axis, and we need to calculate the MI about AB axis. So we won't see about the vertical axis, that is Y axis. So here is the centroid of this first rectangle. Now if I draw the x1 axis of this, okay, so this is my x1 axis. This is my x1 axis. So if I write here, this axis is x1 x1 for the first figure, x1 x1. Okay, and now if I calculate this IAB for the first figure, I am talking about just first figure. This is for figure number 1. What should I do? I will take here Ix1 x1 plus what is the formula? A1 h1 square. This is the for the first figure. Similarly, we can do it for second figure. Suppose now this rectangle is my second figure. This is my third figure. Okay. Suppose this is fourth figure. This is fifth one. I will call this figure as the sixth figure, and this is 7. Okay, so just we can calculate Ix1 x1 and we can transfer that moment of inertia to the axis AB. Okay, so now if I locate for the second figure, see second figure, I know that the centroid of the second figure may be situated somewhere here. So if I draw the axis, that axis will be like this. This is the axis. So I will call this axis as x2. Similarly, if I show the centroid of third figure, the centroid may be situated somewhere here. And if I draw the axis will be, it is like this. This is the axis. And I will call this axis as x3. X3. If you move to the fourth figure, so this is your fourth figure. Okay, centroid may be situated somewhere here. Here somewhere centroid is there. So if I draw the axis, this is the axis of the fourth figure. So I will call this axis as x4, x4. Okay. For fifth figure again, somewhere here the axis will be there. So I will call this as x5. This is x5. Similar cases with the sixth figure. Okay. So for the sixth figure, here somewhere the centroid is there. And if I draw it, it is like this. Sixth and seventh figure. Okay, this is my x6, x6, and this is x7. Okay, so what I need to do now, this is my main axis AB about which I want to calculate the moment of inertia. So first figure, if I calculate x1, x1, I can transfer this moment of inertia to AB by using this parallel axis. Similarly, I will calculate x2. Again, I will transfer this moment of inertia to AB by adding the term plus Ix2 x2 plus A2 h2 square. For third figure again, I will do the same thing. Okay, so if I write the overall formula, see if I write this for every figure, then it will be a big formula. It will be, if I write here, IAB is equal to, suppose now the first figure is there. So I can write here I x1 x1 self moment of inertia of first figure plus A1 h1 square, where h1 is the distance between x1 and AB. Okay, this is for first area. Now for the second area, again I can write I x2 x2. This is the second diagram. Okay, x2 x2 plus A2 h2 square. Now it is not deducted, so addition is there. Again for third figure it will be same due to symmetry. Okay, you can multiply this by 2 also, or you can separately add. Okay, you can separately add over here, or you can itself here you can multiply it by 2. कळतं ना 2 ने का मल्टिप्लाय करायचं, का करायचं तर इथं बघा हा जेवढा रेक्टँगल आहे तेवढाच हा रेक्टँगल आहे आणि सिमेट्रिक आहे फिगर. इफ यू सी अबाउट y axis दिस फिगर इज सिमेट्रिक. ओके, सो I x2 x2 चा जो काही मोमेंट ऑफ इनर्शिया मी इथं ट्रान्सफर करणार आहे तोच I x3 x3 चा येणार आहे. ओके, सेम मोमेंट ऑफ इनर्शिया विल बी देयर. सिमिलरली x4 x4 चा जो काही मोमेंट ऑफ इनर्शिया येईल तोच x5 चा येणार. आणि सिमिलरली जो काही x6 चा मोमेंट ऑफ इनर्शिया आपण ट्रान्सफर करणार आहे AB ला सेम कुणाचा येईल, x7 चा येईल. हे समजलं का? इज इट क्लियर? Yes, no, Sanga, so that, or otherwise we will write separately. If you won't understand this directly, we will write each and every term. What should we do? लिहायचं आहे का सगळं? Okay, for online, Have you understood this?
Yes, sir.
Okay. So what I will do now here, I will multiply this by 2. Okay, I will multiply this by 2. 2 into the next term is there. Why 2 into? Because second area and third area is having same dimensions, same location. That is why whatever I will get the moment of inertia by transferring this x2 to AB, same will be there for x3 also. So I am multiplying it by 2. So now there is no need to take the x3 because we have considered it in here only. Okay, so this is for figure number 1. This is for figure number 2 and figure number 3 as well. Okay, for both the figures we have considered over here. Now if again I will add plus I x4 plus a4 h4 square. Again same thing is there, whatever there is for x4 same will be there for x5. So again I will multiply this term by 2. So this is for your figure number 4 and figure number 5. Because I am multiplying it by 2, instead of writing it 2 times I am directly multiplying it here by 2 because everything is same. Again plus next term is I x6 plus a6 h6 square. Again h6 and h7 having same area, so again I will multiply this by 2. So this is for area 6 and area 7. So all areas are covered. Otherwise, if you won't understand this, you can write it separately for each and every area. I have already told you how to write this parallel axis theorem. Okay, but it is simpler and easier if you write it like this. So now we need to find out all these values, so that we can easily find out. So here, first of all, I will start with x1. First figure. Now see this x1 axis. This is the diagram. This dimension is 400. This is 20. So it is 400 by 20. X1 axis is cutting the dimension of 20 mm. This dimension is 20. So I will write here 400 into 20 cube divided by 12. What is the answer? 2.6 into 10 raised to 5 mm raised to 4. Okay, this is for x1. Now calculate x2. I x2 or you can calculate a1 h1 also. पहिल्या फिगरचं complete करा, मग दुसऱ्याचं करा, तिसऱ्याचं करा. In whatever way you like, you can do it. Okay. So here x2, what is the value? So now this is the x2 second area. This value is 10. Here it is given 10. This is 10 and this horizontal value is 100. Here it is given 100. So this is 100 and this is 10. So your x2 value is cutting the dimension of 10 mm. So it will be 100 into 10 cube divided by 12. What is the answer? 8.3 into 10 raised to 3 mm raised to 4. Similarly, if I see x4, now this area I should consider, this one. Okay. Now here you can see from this point up to here, this depth is 380, but this much is of 10 mm. Here it is 10 mm. So from this point to this point, this area will be how much? What is the length? It is 370 because this total is 380 and out of which this much is 10. Here this much is 10. This total is 380. So from this point up to here, this will be 370. Okay. So this is 370. And what is the thickness? Thickness you should also take it as a 10. Okay. This thickness is also 10 mm. I have not written over here. So this thickness is also 10. So this is 370 by 10 and this x4 axis is cutting the dimension of 370. So I can write here x4 is equal to 10 into 370 cube divided by 12. What is the answer? 4.2 into 10 raised to 7. Okay, after this x4, whatever x4 is there, x5 will be same. Then come to I x6. x6, which is equal to, now this x6 again, this is by, this is how much it is, 10 by 100 again. So it will be 100 into 10 cube divided by 12. How much? 8.3 into 10 raised to 3 mm raised to 4. Okay, now we will calculate A1 and all the distances. Okay, areas we will calculate now first. First is the area of first figure, A1. A1 is equal to, what is the area A1? It is 400 into 20. A1 is 400 into 20. So how much it is? 8,000 mm square. Then A2. A2 will be, it is 10 into 100. 10 into 100. So it is 1,000. Okay. Then A2 is 1,000. So your A3 is also 1,000. A6 is also 1,000. A7 is also 1,000. Okay. As these four rectangles are same. So A2, then A3. I will write here A3, which is equal to A6, which is equal to A7, which is equal to 1,000. Okay. And then A4, which is equal to A5, which is equal to, this is equal to A4, A5, this is 370 and this is 10. So it is 10 into 370, which is equal to 3700 mm square. These all are the areas. Now H1. What is H1? See here, H1 is here and AB is here. Okay, so the distance between x1 and AB is nothing but H1. इथला ऍक्सिस बघायचा, H1 कॅल्क्युलेट करायचं ना, इथं कोण आहे बघायचं, x1 आणि AB यांच्यातलं डिस्टन्स घ्यायचं. सो x1 आणि AB यांच्यातलं डिस्टन्स किती आहे? हे 20 आहे ना, हे 20 आहे म्हणजे हे किती असायला पाहिजे? 10. हाफ रेक्टँगल b/2 d/2. This will be 10 and below it is also 10. This 20 gets divided due to this centroid. So the H1 is 10. H1 is the distance between x1 and AB. So this is your H1. हे जे distance आहे, हे distance तुमचं H1 आहे. Okay, so this is 10 mm. Then H2 is equal to, so H2, if I want to calculate H2 is, here is the axis. Okay, so हे जे इथून ते एवढं डिस्टन्स असणार आहे इथपर्यंत, हे असणार आहे तुमचं H2. Okay, this will be your H2. Now how you can calculate H2? So this is 10. This total is 10. म्हणजे हे एवढं किती असणार आहे? 5. बरोबर आहे. हे किती आहे? 20. 20 plus 5. So it is 25. So H2 is 25 mm. Okay. After that H4. H4 म्हणजे कुठून कुठला असणार आहे डिस्टन्स? So H4 will be the distance of, see, from x4 to this AB. इथं बघायचं आहे, H4 कॅल्क्युलेट करायचं आहे. कोण आहे इथं? x4. कुणा बरोबर करायचं आहे? AB. सो ह्या दोघातला डिफरन्स लागणार आहे तुम्हाला. x4 आणि AB मधला डिफरन्स म्हणजे H4 असणार आहे डिस्टन्स. सो दिस इज युअर H4. This distance is your H4. So how much it is? See, this is 20, you already know. This is 10, this also you know it. So what is remaining? This area. So this is 370. The total 370 आहे. म्हणजे एवढं किती असणार आहे? या पॉइंट पासून इथपर्यंत किती असणार आहे? 370 by 2. How much it is? 185. So this much is 185. मग आपल्याला हे टोटल पाहिजे. टोटल पाहिजे म्हणजे काय करावं लागेल? This 185 plus this 10, 195 plus this 20. This is 20. म्हणजे या टॉप पासून डिस्टन्स मिळाला आपल्याला एवढं. So 185 plus 10, 195 plus 20. It is किती?
215.
215. So your H4 will be, your H4 is 215 mm. Okay. Similarly, now see H6. H6. इथं कोण आहे x6. सो x6 and AB यांच्यातलं डिस्टन्स पाहिजे आता आपल्याला x6 and AB. Now if I mark over here, see here is the position of x6. If I extend this, this is the position of x6. Okay, and we want this distance now x6. This is our final distance, that is h6. This is h6. So what is that distance? इकडे बघा हे किती आहे टोटल.
120.
हे मला टोटल सांगा. या पॉइंट पासून इथं खालीपर्यंत किती आहे टोटल. हे 20 प्लस 380 म्हणजे किती झालं 400. ओके 400 आणि हे खाली किती आहे 10. सो टोटल इज 410. सो दिस टोटल इज 410. म्हणजे इथून ह्या बॉटम पासून ते वरपर्यंत 410 आहे. आता ह्याचा सीजी इथं आहे. हे डिस्टन्स किती आहे 10 आहे. टोटल 10 आहे. 10 आहे म्हटल्यावरती त्याच्या हाफ किती झालं 5. सो हे खालचं डिस्टन्स किती असायला पाहिजे हाफ म्हणजे 5 आणि हे वरचं पण किती असणार आहे 5. सो दिस टोटल इज 410. सो इफ यू मायनस दिस 5 फ्रॉम 410 you will get h6. So it will be 405. So h6 is 405 mm. Okay, so put all the formulas in the equation. So I can write here Ixx is IAB है ना, xx लायची सवय लागली. So IAB is equal to, my first x1 is, it is 2.6 into 10 raised to 5, 2.6 into 10 raised to 5 into A1 is 8000 into H1 is 10 square, plus second figure is 2 into in bracket x2. So x2 is 8.3 into 10 raised to 3. So it is
प्लस येते
काय
2.6 into 10 raised to 5 plus into 8,000.
now it is right.
Yes sir.
8.3 into 10 raised to 3 plus here what is the area A2 is 1000 into H2 is 25 square. Okay, again plus 2 into in bracket, here it is x4 is 4.2 into 10 raised to 7. So it is 4.2 into 10 raised to 7 plus area A4 is here 3700 into H4 is 215. Okay, and plus last term is plus again 2 into x6. So again 2 into x6 is 8.3 into 10 raised to 3 plus here x6 is 1000 into distance is 405 square. So if you solve this, you will get the value of IAB. जसे मी ब्रॅकेट टाकले असे ब्रॅकेट टाकून सॉल्व करा. और सेपरेट सॉल्व करा आणि ऍडिशन करा कसंही करा.
सर ते कॅल्सीवर बॉक्स ब्रॅकेट
किती आला 7.56 into okay 7.56 into 10 raised to 8. Okay, here 8.06 answer is there. Okay, let it be. We will verify. So I have got the answer. Kiti 7.56. 5, 6 into 10 raised to 8. Please check this answer. Is it right? Check this answer and let me know whether it is right or any different answer is there. What is the answer? Nobody is giving me the confirmation. वेगळं आलं असलं वेगळं सांगा. Is this answer is right?
Sir, it is correct.
It is correct? Okay.
Yes, sir.
Okay, so I have got one confirmation. What about the others? तुमचं सोडून झालंय का? किती आलं?
Sir, it is correct.
Loudly. नाही 2.08 येत नाही. Check the calculation once again. Check you have done
7.56
properly
into
square or you should add everything. Then once you add, now you are saying in 10 raised to 8. If you see the quantities 10 raised to 5, 3, 7, 3, so 2.6, 8.3, 4.2, 8.3, and all everything addition is there. So 2.03 is very less. It will not be the answer. This 7.56 I have got confirmation. This is the correct answer. So check the calculation.
Sir, it is correct answer.
7.96. Okay, it is also correct. 7 point something if you are getting, then it is correct. The variation in the answer is due to the how you input the values in the calculator. That is the difference. Okay. Because of decimal points, there is variation in the answer. Okay. So now we will take the next numerical and last numerical of this. Okay, this unit. A T section. A T section is to be strengthened by adding 10 mm thick plate on the upper side of the flange as shown in figure. Full stop. Determine the width of plate. Determine the width of plate so that so that centroid of composite section centroid of composite section centroid of composite section lies at 200 mm lies at 200 mm from the bottom of the web. Now I will draw the diagram. T section. This is a T section, and on this T section, a plate is added which is symmetrically placed. Okay, so I will add that plate. In this way, a plate is added. This is the plate which is added. Okay. So now what they have given us, they have given the dimensions. So the dimensions are this flange, the total flange, it is 200 mm. This is 200 mm. Then the thickness of plate, this thickness, okay, so it is not visible. So what I will do, this thickness, this is how much? It is 10 mm. This is 10 mm. Then this is 20 mm. Width of flange is depth of flange is 20 mm. Then width of web, this is also 20 mm. And the height of web is 250 mm. So this is 250 mm and this is 20 mm. Okay, here you add in the problem, also find out mi about centroidal horizontal axis. We will add this in the problem. Actually, the problem, what is asked, the problem which I have write in the brown ink, that is asked. Okay, this pink, whatever I have added by this pink ink, it is extra that we will calculate. Okay. Now read the problem and you tell me what to do. So let us say that we don't know the width of this plate. Okay, let us say that the width of this plate is B. We don't know the width. Let us say that the width of this plate is B mm. This is B mm. This is the width. Now think on this and let me know how to solve this. Read the problem first. A T section is to be strengthened by adding 10 mm thick plate. Okay. So it is originally the T section was there. So on this T section, this 10 mm thick plate is added on the upper side of the flange. So this is flange. If they say that at the lower side of the web, then here you should add. But they have told us on the upper side of the flange. So here is the plate. Determine the width of the plate. So what is the width of this plate? This you need to calculate. Okay. So that the centroid of composite section lies at 200 mm from the bottom of web. So this composite section, whole section, the centroid of this whole composite section, here they have mentioned that centroid of composite section lies at 200 mm. किती distance वरती आहे 200 mm वर. कुठून? From the bottom of web. So from bottom it is at a distance of 200 mm. So if I show you the centroid is, they have told us somewhere here at a distance of 200 mm. So here somewhere the centroid will be there. Okay, and if I draw the centroidal axis, so this will be the centroidal axis. This is the centroidal axis. This is your x-axis axis of this I section. Why? Because it is given in the problem 200 mm from bottom of web. Okay, centroid of the composite section. Everything is given. I have underlined those words. You should also underline it. While afterwards, when you are studying this, you will understand why I have underlined there. Okay, you should read the problem carefully. What is given? So this distance they have given to us. This distance is being given to us, and this is 200. This is 200 from bottom. Okay. So now what we will do? कसं काढायचं बी? काय करणार? विचार करा बरं. It is very simple. Use the formula of y bar. दरवेळेला तुम्हाला काय केलेलं असतं, हे सगळे डायमेन्शन्स दिलेले असतात आणि तुम्हाला x बार आणि y बार काढायचं असतं. यावेळेला तुम्हाला y बार डायरेक्टली दिलेलं आहे ना. This 200 mm is nothing but the distance of the centroid of total T section. This total composite sectionच्या centroidचं distance तुम्हाला दिलेलं आहे. म्हणजे डायरेक्टली तुम्हाला y बार ची व्हॅल्यू दिलेली आहे बॉटम पासून. ओके, सो हियर I will write. It is given that y bar is equal to how much? 200 mm. Okay, y bar is 200 mm because this is the centroid of total figure. This is not the centroid of this rectangle. Okay, this is the centroid of this total figure. म्हणून याला आपण y bar म्हणतो. Okay, so the formula for y bar is equal to a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. So now I will name the areas. Let us say that this rectangle is my area number 1, this rectangle is area number 2, and this plate is area number 3. This plate is area number 3. So we will write the values. Y bar. What is y bar? Y bar, it is given 200 mm. So I will write here 200 is equal to y bar. It is already given. Y bar is 200 mm, which is equal to A1. A1 is the area of the first figure. So this is 20, and this horizontal is 200. Okay, so it is 200 by 20. So I can write 200 by 20 into y1. What is y1? So y1 is the distance of the centroid of the first figure from reference x-axis. So our reference x-axis is always at the bottom. We always consider here our reference y-axis and here is our reference x-axis, so that our figure should be in the first quadrant. Okay. Now you should imagine this. Every time there is no need to draw this x and y axis. Okay, you should imagine this always. So now this is your y1. So now what is the value of y1? So this total is 250. From bottom, this is 250. Above it is 20. So centroid, then it will divide this 20 into two parts, 10 and 10. So it will be 250 plus 10. This will be 10. This is 10. 250 plus 10, it is 260. This is your first figure, A1 Y1 plus A2 Y2. So second is this rectangle. So this dimension is 250. This is 20. So it will be 20 by 250 multiplied by Y2. y2 is the distance of the centroid of the second figure, okay, from bottom. Distance of the centroid of the second figure from bottom. So that will be your y2. So I will show here, this is y2. So how much it is? If this total is 250, this is rectangle, so half of that, how much it is? 250 divided by 2, so it is 125. हे जे आता मी जसं कॅल्क्युलेशन करतोय ना, असं तुम्हाला एक्झाम मध्ये डायरेक्ट कॅल्क्युलेशन यायला पाहिजे. Then only you can save your time. Okay. Plus last area is A3. Now A3, this width is 10. This dimension we don't know. We assume this as a B. So it will be B into 10. Okay, into Y3. Y3 is what? Distance of the centroid of this figure. Okay, distance of the centroid of this figure from bottom. Okay, so how much it is? If this total is 10, then the centroid will be at 5, 5. Distance will be 5 and 5. So the total is 250 plus 20. It is 270. And in that you should add 5. So it will be 275. It will be 275. And whole divided by A1 plus A2 plus A3. So A1, your A1 is 200 into 20. So I can directly write the values over here by multiplying itself. So your A1 will be 200 into 20. So it is 4000 plus A2 25 50 and 00 5000 plus your A3 is 10B. So now there is only one unknown B. You can simplify this and find out the value of B. Reshuffle kara term. 180 alika exactly. So B is equal to 180 mm. This is the answer. Verify the answer also. This is the answer. B is equal to 185 mm. Okay. Now how you will calculate Ixx? Parallel axis theorem. आता पुढची गोष्ट सोपी आहे. तुम्हाला Ixx काढा म्हटलंय ना पुढं. So if I draw all the axes, see, this is the axis of my first figure. This is the x1. Okay, this is the x1 axis. This is the axis x1. Then second will be here. This is the axis x2. Okay, so this is my axis x2. And where is x3? So here, this is the axis x3. This is the axis x3. So use the parallel axis theorem to calculate. Okay, so if I use the parallel axis theorem and if I write the formula, then what is the formula? It will be Ixx is equal to Ix1 three figures are there, plus A1 H1 square plus Ix2 plus A2 H2 square plus Ix3 plus A3 H3 square. So now calculate Ix1 first. So now if I calculate Ix1 then it will be first figure. So this x1 axis is cutting the dimension 20. So it is 200 into 20 cube by 12. So door close kara. So it is 200 into 20 cube by 12. Calculate this. What is the answer? 1.3 into 10 raised to 5 mm raised to 4. Okay, others please do check the answers. X2 is this second figure. So area of this second figure is this much. This is 250. So this x2 axis is cutting the dimension of 250 for this figure. So it will be 20 into 250 cube by 12. So it is 20 into 250 cube by 12. What is the answer for this? 2.6 into 10 raised to 7 mm raised to 4. And finally, x3 is the plate. Okay, now you know the width 180. So this is 180 and this is 10. B is 180, 10. X3 axis is cutting the dimension 10. So it is 180 into 10 cube divided by 12. It is 15,000. So 15 into 10 raised to 3 mm raised to 4. A1, A2, A3 you have already calculated, I think, here. Just A3 you have to put here instead of B, 180. So here H1, then H2, and then H3. So H1 is, if I see H1 म्हणजे कशा distance येणार आहे H1 is equal to the distance between this X and X1. This is your H1. हे जे मधलं distance असणार आहे ते असणार आहे तुमचं H1. Okay. So here this is your H1. हे जे distance असणार आहे हे असणार आहे H1. So how much it is? Here 200 आहे ना, total to 270. So H1 will be 70? 70 plus 10. Okay, correct. So this is here, this is 250. 250 means this is 125 from here. So 125 from this point here minus 10. So it is 105. 105 minus 10. So it is 85. So it is 60. What is H1 you have told? चुकीचं घेतलं ना, तेच म्हणलं मी, असं कसं काय आलं बघा. हे 200 y बार 200 म्हणजे टॉप पासूनचं डिस्टन्स किती आहे या प्लेट पासून सांगा मला. प्लेट सहित आहे आपलं मोमेंट ऑफ इनर्शिया. हे डिस्टन्स किती झालं टॉपचं, एवढं किती आहे, हे टोटल किती आहे 250 plus 20 plus 10. So total is 280. 280 out of which this is 200. So what is remaining? 80 is remaining. So from top it is 80. So from this 80 now, if I minus this 10, then I will come to this level. So it is 70 now. From 70 again this is 20. So if I minus this 10 also, this is also 10. So if I minus this 10, then I will come at this level. So it is 60. So H1 is 60 mm. Then again H2. H2 is this much of distance. So if I show you H2, so from X2, sorry, from X2 to X, this is your H2. So what is the distance? What is the distance? This is 200. This is 200. And if Y2 किती आपला 125 है ना ये. This is 125 and this is 200. So 200 minus 125. What is H2? 75. And H3 is, this is here, it is X3. So H3 will be this distance from X3 to X. This is your H3. Okay. So it is 80, this total from top of the plate, it is 80. We have calculated 80. So this is 10, so minus 5. So it will be 75. So H3 is 75. So put all the values in the formula and get the answer. So the Ixx is equal to here 1.3 into 10 raised to 5 plus A1 is 4,000 into 60 square plus here X2 is 2.6 into 10 raised to 7 plus A2 is 5,000 into 75 square plus X3 is 15 into 10 raised to 3 plus A3. So A3 area is 10 into B, so 180 into 10. 180 into 10 is 1800 into here H3 is 75 again. So 75 square. So after solving, you will get here Ixx. Okay. So write the value over there. What is the answer? You tell me and write the value. What is the answer? 7.8 into 10 raised to 7. Okay. 7.8 into 10 raised to 7 mm raised to 4. Please verify the answer. This is your final answer. Okay. Today we will stop over here. So in the teaching diary, I have uploaded you the MCQ questions link. Okay. MCQ questions link I have uploaded there. So you go there and check the MCQ of this unit. Okay. In the teaching diary, link is given to you. So from the next lecture, we will start the, what we can say, next unit, second section. So at, okay. For today,